So then the problem we have here is that 0 is smaller than 1. So we need to borrow a unit from this 1 next to it. So that 1 becomes a 0. But that unit that we borrowed from this place is worth 2 in this place. And the reason for that is, if you think about it, let's say we had the number 24 minus 9. We would have to borrow a unit from the 2, and this one will become a 14. So that means we borrowed 10, even though for this 2 it was only worth a 1. So what we're doing is we are borrowing the base. For this case, we're borrowing a 10, because that's base 10 arithmetic. For the binary case, we're borrowing a 2, because that's a binary number, which is base 2. So we're borrowing the base. Every unit is worth the base. So 2 minus 1, 1, 0 minus 0, 0, 1 minus 1, 0. So the answer is 1. And that's what we should get, since this was 6 and this was 5. 6 minus 5 is 1. So let's go ahead and look at a more complicated example. So let's say we have the number 24 in binary, and we wanted to subtract a 9 from it. So what we have is that this 0 needs a unit so that we can subtract 1 from it, but it can borrow from the next 0 because that one also doesn't have anything to lend. So it goes to the next one. That one doesn't have anything to lend either. So then we get to the 1. So then we borrow a unit from this 1. So it becomes a 0. Now this 0 becomes a 2, but it wants to lend 1 unit to the other 0. But you got to remember that that unit is worth 2 in this place. But we're not done yet, because we need to lend a 1 to the last 0. And so this is what happens. So now 2 minus 1 is 1. 1 minus 0 is 1. 1 minus 0 is 1. Once again, we have the same problem. We have 0 minus 1. Just borrow a unit from here. That makes this 0 a 2. 2 minus 1. And this should be a 0, I'm sorry, since we borrowed a unit. So 2 minus 1 is 1. And our answer is 15. And that's what we expected, since this is 24 and this other number is 9.